Hello my dear students, this is Dr. Vivek Rohira, Mathematics Mentor. So today we are going to start in chapter number 1, Real Numbers. The next topic, Fundamental Theorem of Arithmetic. Okay, so the next topic in the chapter number 1, Real Numbers, we are going to start Fundamental Theorem of Arithmetic. So in the lecture 1, you understand about the basic introduction of real numbers. Okay, that is what is real numbers, how it is connected with rational and irrational numbers. Now we use all these numbers, or we use the real numbers basic concept to understand the fundamental theorem of arithmetic. So let me start. So fundamental theorem of arithmetic. What is the meaning of fundamental theorem of arithmetic? That is, every composite number can be expressed as the product of primes, which is unique. That is, if there is any composite number we have to given, then it can be break into the form of prime numbers. Okay, and these all prime numbers will be unique. That is called the prime factorization. Okay, that is called the prime factorization. So now what is the prime factorization? If we are taking any composite number capital N, then according to that theorem, this composite number can be break as P1, P2, P3 up to Pn. That is, this composite number can be written in the product of prime numbers which are unique. That is P1, P2, P3 up to Pn, they all are different. Okay, so this is the meaning of primes, product of primes which is unique. So this is product of primes which all are unique. Now the next thing. This is we have studied the fundamental theorem of arithmetic, that is the composite number can be written in the form of product of prime numbers which are unique, and this is called the prime factorization. Now what is the major application of this prime factorization, or we can say of this fundamental theorem of arithmetic? So the major application we are going to study here, which having the 1 mark or 2 mark questions, or sometimes it have the 3 marks questions also in the CBSE. So the major application we will learn here to find highest common factor and LCM, that is the lowest common factor or least common factor. So the major application is to find the HCF and LCM of the given numbers. Okay, so let me start. That is how we will find the HCF and LCM of given numbers by the help of prime factorization. So here we will taking an example, that is we have to find the HCF and LCM of 180 and 54. So here we have to given two numbers and we have to find their HCF and LCM. Okay, so first we do their prime factorization. As the first number is 180, so when we will do the prime factorization of 180, then it will be equal to 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 5. Okay, so this is the prime factorization of 180. Also, it can be written in the form of 2 square, because 2 is repeating 2 times, okay, or multiplying 2 times. So it can be written as 2 exponent 2 multiply 3 exponent 2 or 3 power 2 multiplied 5 raised to the power 1, or simply we can write 5. So these are the prime factorization of the number 180. Now in the same way, we can do the prime factorization of 54 also, and it will be equal to 2 multiplied by 3 multiplied by 3 multiplied by 3, and this can be written as 2 multiplied by, now 3 comes 3 times, okay, 3 is multiplied 3 times, so it can be written as multiplied by 3 raised to the power 3. So first, to find the HCF and LCM of 180 and 54, first we find their prime factorization with their respective exponent. Now we have to find HCF. So what is HCF? HCF is the product of the least power of common prime factor of the numbers. Okay, the numbers which we are going to find the HCF. So we have to given two numbers or more than two numbers which we have to find the HCF. So firstly we have to find their common prime factors, okay, with the least exponent. So 2 points are very important. The first one is least exponent and the second one is common prime factor. So whenever we are going to find the HCF, so 2 points we should know. The one is least power or least exponent of what? Common prime factors. Okay, so here we can see that to find the HCF, so HCF will be, or we can see the common prime factor. So the common prime factor are 2 and 3. 2 and 3. Okay, so the common prime factor we will write down 2 and 3 with least exponent. So we can see that the least exponent of 2 in both of them is 1 and the least exponent of 3 is 2. So we have write down the common prime factor with their least exponent. Okay, so we find that is this is equal to 18. So the HCF or highest common factor of 180 and 54, that is equal to 18. Now we have to find LCM. So what is LCM? LCM is the product of highest power. So here the important point is highest power we have to take. Now whose highest power we have to take? Of all prime numbers, not common prime numbers, of all prime numbers. All prime numbers, that is we have to check which prime factor in the first number we have to given, which prime factor we have to given or we find in the second number. So all the prime factors we have to take with their highest power. Okay, so when we are going to find the LCM, then we can see that all prime factors, so we have to take 2, 3, 5. Okay, then 2 with the highest exponent, that is 2, and 3 with the highest exponent, that is 3, and 5 with the highest exponent, that is 5. Okay, so now this is 4, this is 27 and this is 5. So 4 into 27 into 5 and it will be 540. Okay, so we find the HCF of both number is 18. The HCF of both number is 18 and LCM of both number is 540. So the first application we understand here, that is how we find the HCF and LCM by the help of fundamental theorem of arithmetic or by the help of prime factorization. Now the next thing, can we find a relation between HCF and LCM of two numbers and the product of that numbers? So that's we want to check. So when we do the product of HCF and LCM, that is 18 into 540, then we find that this product will be equal to 9720, that is 9720. And also if we find the product of the numbers, that is 180 into 54. Okay, so 180 into 54 we will find this is also 9720. So we find that HCF into LCM is 9720 and the product of the number is also 9720. So here we find a interesting result, okay, or we can say an interesting relation we have find out between the product of the numbers and their HCF and LCM. Okay, so what we find, that is HCF of two numbers multiplied by LCM of two numbers will be equal to product of both numbers, that is A cross B. So this is very important relation. Very important relation. So there are many questions based on this relation. Many questions, that is, the one of the questions may be asked to verify that relation. One of the questions in which we have to given the product of the numbers, and one of the thing we have to given, that is LCM, or we have to find the HCF. Okay, so because we can check that either we have to given the product of the numbers, either we have to given the HCF or LCM. Okay, so by the help of the given quantities we can find the unknown very easily. Either the numbers we can find out, either the HCF or LCM we can easily find out by this relation. Okay, so here we understand this first concept based on fundamental theorem on arithmetic. Now the next, now we start exercise 1.2 based on this fundamental theorem of arithmetic or prime factorization. So firstly, in exercise 1.2 NCERT, there are some of the questions in which we have to learn, that is how we prime factorization of the numbers. So let's see, we have to given first of the question, that is express each number as the product of its prime factors. Okay, so the first number 140 we have to express as the product of prime numbers. So we do factorize. So now 140 firstly divided by 2, then it will be 70. Then again 70 divided by 2, then it will be 35. Okay, then again 35. Now divided by 5, then it will be 7. So finally we found that the prime factorization of 140 is equal to, again 7 divided by 7, that is 1 time. Okay, so it will be 2 multiplied by 2 multiplied by 5 multiplied by 7, and 2 is coming 2 times. So we can say that 2 raised to the power 2 multiplied by 5 multiplied by 7. These are the prime factorization of 140. So finally 140 can be written as 2 square into 5 into 7. So this is the prime factorization of 140. The next one, we have to find the prime factorization of 156. So the same way, 156 firstly divided by 2, then it will be 78, then again divided by 2, then it will be 39, then again divided by this 3, then it will be 13, and divided by 13, then it will be 1. So here the prime factorization of 156 will be 2 square into 3 into 13. Okay, so this is the prime factorization of 156. Now the third part is 3825. We have to do the prime factorization. Okay, last digit is 5. So firstly divided by 3. Okay, and we can see that when divided by 3, then it will be 1275. Then again it may be divided by 3, that is it will be 425. Then divided by 5, then it will be 85. Then again if it will be divided by 5, then it will be 17, and 17 is a prime number. Okay, so 17 divided by 17 is 1. So here we found that the prime factorization of 3825 will be equal to 3 square into 5 square into 17, because 3 coming 2 times and 5 is also coming 2 times. So that's why 3 exponent 2, 5 exponent 2 into 17, right? So this is the prime factorization of 3825. So we see the next question based on this one. So again the next question we have to given fourth part is 5005. So when we will divide it by 5, then it will be 1001. It will be again divided by 7. How we recognize then the number will be divided by 5 or 7 or 9, etc. Okay, so you should know the divisibility concept of the numbers. Okay, the divisibility test you should know, that is divisibility test by 2, 3, 4, 5, 6, 7 up to so on. Okay, so now 143, that is divided by 11, then again divided by 13, it will be 1. So the prime factorization of 5005 will be equal to 5 into 7 into 11 into 13. The next one 7429. So in the 7429 we can see that firstly divided by 17, okay, and it will be 437, then divided by 19, then it will be 23, and now 23 is a prime number, so 23 divided by 23, then it will be equal to 1. So the prime factorization of 7429 will be equal to 17 into 19 into 23. Okay, so this is the prime factorization of 7429. So now the next extra questions based on this one, that is we have to express 1000 as the product of prime numbers. So it can be easily done, divided by 2, then 500. Okay, then divided by 2, then it will be 250. Okay, divided by 2, then it will be 25, then again divided by 5, it will be 25, again divided by 5, then 5, then again divided by 5, then it will be 1. So here the prime factorization of 1000 will be 2 raised to the power 3 and 5 raised to the power 3. Okay, so it can be written as 2 raised to the power 3 into 5 raised to the power 3. Right, so this is the prime factorization of 1000. In the same way, next question we have to given the prime factorization of 72. Very simple question. Okay, divided by 2, then 36, then divided by again 2, then this will be 18. Okay, then divided by 2, then this will be 9, then divided by 3, then this will be 3, and again divided by 3, then this will be equal to 1. So the prime factorization of 72 will be equal to 2 cube into 3 square. Okay, so this is the prime factorization of 72. So here firstly in exercise 1.2 we understand that is how we find the prime factorization of the given numbers, right? So this is the first point we learn here. The next one, question number 2 of the exercise 1.2 NCERT. We have to find the HCF and LCM of the given pairs of integers, and we have to verify also the relation, that is HCF into LCM will be equal to product of prime numbers. Okay, so both points we have to find out. The number one is LCM and HCF, and also we have to check the relation, right? So the first question we have to given 510 and 12. So first 510. So when we do the 510 factors, then it will be divided by 2, then divided by 3, then divided by again 5, then it will be 17, then 17 divided by 17, it will be 1. So here we found that the prime factorization of 510 is 2 into 3 into 5 into 17. So we will write down prime factorization of 510 is 2 into 3 into 5 into 17. The next one, we have to given 12. So 12 prime factorization also we can do very easily. Okay, so it will be divided by 2, then 6, then divided by 2, then 3, then divided by 3, then it will be equal to 1. So the prime factorization of 12 is 2 square into 3. This is the prime factorization of 12. Now we have to find HCF of 510 and 12. Then we can see that what is the HCF? Highest common factor is what? That is the common prime factors with least exponent. Okay, so only the first one is the common prime factor is 2 and least exponent is 1. The next common prime factors we can check, then it will be 3. Okay, so there are two common prime factor, 2 and 3, with the least exponent, that is 1, so it will be equal to 6. So we find that HCF of 510 and 12 is equal to 6. And also in the bracket again we write down the definition of highest common factor, that is the product of common factors or common prime factors raised to the least power. Okay, so this is we find the HCF. And similarly LCM of both numbers we can find out. LCM we have to take all the prime factors, that is we have to take 2, 3, 5, 17 with their highest exponent. Okay, highest exponent of 2 is 2, highest exponent of 3 is 1, highest exponent of 5 is 1, and highest exponent of 17 is 1. So the LCM will be, when we will multiply all of them, then this will be 1020. Also in the bracket we have write down the definition of LCM also, that is the product of all prime factors raised to highest power. Okay, so here we find the HCF and LCM. Now we have to check the relation also. Okay, so we have to verify. So to verification, we firstly find the product of LCM and HCF, that is the product of 1 0 2 0 and 6. Both product we will find out. Okay, so when we will find out both product, then it will be 1 0 2 0 and 6. Okay, then it will be equal to 6 1 2 0. Okay, and also we have to find the product of both the numbers, that is the product of numbers, that is 510 into 12, and we find that this is also equal to 610. They both are same. So here we verified that LCF into SCF is equal to the product of the two numbers. Okay, so here in the question number 2 we find HCF and LCM, as well as we find their relation also, right? So this is we have done in question number 2. The next question number 2 part is 336 and 54. So same process we have to do with both the numbers. So firstly 336. So 336 we will do the prime factorization, divided by 2, then 168, then divided by 2, then 84, then divided by 2, then 42, then divided by 2, then it will be 21, then divided by 3, then 7, then it will be 1. Okay, so here you can also check, we are just write down the prime factors in the increasing order, first 2, then 3, then 7. Okay, so this sequence you should also know. So now we can write down, that is it will be 2 raised to the power 4 into 3 into 7. Okay, so this is the prime factorization of 336, right? And the next one is 54. So for 54 we can do also the prime factorization, divided by 2, then it will be 27, that divided by 3, then it will be 9, then divided by 3, then it will be 3, then again 3 is divided by 3, then it will be equal to 1. So it can be written as 2 multiplied by 3 raised to the power 3. Okay, so it will be 2 multiplied by 3 raised to the power 3. So firstly we do the prime factorization, same process we follow. After that what we will do, we just find their SCF. Okay, SCF we have to take the common prime factors, that is common prime factors are 2 and 3. Okay, and both we have to take with their least exponent. So we can see that the least exponent of 2 is 1 and least exponent of 3 is also 1. So it will be equal to 2 multiplied by 3, that is 6. Okay, very simple. I think it is very simple. Okay, to find the SCF. And also the LCM of both numbers, that is we have to take all the prime factors, that is 2, 3, 7 with their highest exponent or highest power, that is 2 with the power 4, 3 with the power 3 and 7 with the power 1. So it will be equal to 3024. So we find LCM is 3024 and SCF is 6. Now again the point of verification. So to find the verification, we find the product of LCM and HCF, that is 6 into 3024, and it will be equal to 18144. Okay, right? So 18,144 we find. The next one is product of two numbers, that is 336 and 54. And the product of both numbers also we find that it will be equal to also 18144. So here we found that the relation satisfied, okay, that is LCM into SCF is equal to product of both numbers or product of the given two numbers, right? So this is question number 2 of exercise 1.2. We learned about the same concept LCM, HCF and their relation with the numbers. Okay, so the next question. Again, now here we have to given the three numbers 12, 15 and 21. Okay, but the verification, the relation to check the verification is not given, because the relation which we have learned to find the HCF and LCM of two numbers, that is HCF of two numbers into LCM of two numbers, is equal to the product of the two numbers, not for 3, 4 or up to n. Okay, this is something different topic and you will learn in the higher classes. So here we only find the HCM and LCM, which we can easily find. So firstly we will do the prime factorization of 12, and prime factorization of 12, you can see that divided by 2, then 6, then divided by 2, then 3, then divided by 3, then 1. So it is 2 square into 3, so it can be written as 2 square into 3. Okay, right. The next one is 15. So for the 15 we can check the prime factorization of 15 are divided by 3, then divided by 5. So the prime factorization of 15 are 3 into 5. Very easily we can done. And the calculation whatever we are doing, this is you have to done the calculation in the rough work. Okay, or if you have a time, then you can also show this calculation. It will be more better for you, right? There will be never calculation mistake in the paper, right? So, and all the calculation on the right hand side you have to use the pencil. Okay, by the pencil you can do this all the calculation, then write down the final answer here. So the prime factorization of 15 are 3 and 5, and then prime factorization of 21. So you can see that 3 divided by 21, 21 divided by 3, 7, and then 7 divided by 7 is 1. So it will be equal to 3 multiplied by 7, right? So all the three things we have write down. Now we have to find HCF of all. So common prime factor, if you will see, then this is only 3. 3 is the common prime factor with lowest exponent, that is 1. So HCF will be equal to 3, right? And LCM, if we have to find out all these three numbers, then we have to take all the prime factor 2, 3, 5 and 7 with their highest exponent. 3, 2 square, 5 and 7. Here firstly we have to write down 3, but you can start with the least prime factor, least prime number, that is 2, 3, 5, 7. Then this particular sequence will be more better when we will write down. Okay, and it will be easy to check or easy to verify our answer. So now it will be 420. Okay, so HCF and LCM we find out of the three numbers, right? In the same way, in second part we can see that we have to find the HCF and LCM of 17, 23 and 29. So it is very easy. 17 is already a prime number. Okay, so it will be equal to 17 into 1, and 23 also will be written 23 into 1. 29 also will be written 29 into 1. Very interesting result. Okay, so when we have to find out the HCF of all these three numbers, product of common factors, so it will be equal to 1. That is, when we are find out HCF of prime numbers, HCF of prime numbers, or we can say these are co-prime numbers, so the HCF always will be equal to 1. Okay, so now the LCM, if we have to find out, so we will multiply it. If these all are the prime numbers, so we will multiply it all of them. So it will be 17 into 23 into 29, and this will be equal to 11339, 11,339. Okay, so this is, we have done the question number third, second part. The next one, question number third part, 8, 9, 25. Very simple question. 8 prime factors if you will do, then it will be 2 cube into 1, 9, then it will be 3 square into 1, and 25, then it will be 5 square into 1. So again you can see that here these are not the prime numbers, but if we will find that there is no common factors other than 1, so the HCF will be equal to 1 here, right? And also if we will find the LCM all of them, then we will multiply it the same, 2 cube, 3 square or 5 square, or simply we can say we will multiply all the numbers, right? Product the numbers, then it will be 1800. So we find the HCF and LCM of three numbers. Okay, so this is, we have completed question number 3rd. The next one, question number 4th. We have to given HCF of two number is 9, and we have to find LCM of that number. So for that we will use the relation. Okay, so we will use the relation. So in the relation we will check that HCF, we have to given 9, but we know the relation, that is HCF into LCM of two numbers is equal to product of the two numbers. So we can check the relation. We just write down the relation. So now HCF of both into LCM of both number will be equal to 306. Okay, 306 into 657. So here what we have write down, firstly we have write down the relation. You can check the relation. We have to given HCF into LCM is equals to product of two numbers. So here we have write down the product of two number is 306 into 657. This is the product of two numbers. Now what we have to given? We have to given HCF. So LCM will be equal to product of two numbers divided by 9, that is HCF of two numbers, right? So now when we'll divide it by 9, then 306 cancel out by 9. Okay, that is they both are cancel out 102 times and 3 times by the 3, and the next one is this 102 cancel out by 334 times. Okay, or directly you can cancel out 306 by the 9 34 times. Okay, and now just 34 multiplied by 657, then it will be 22,338. that is the LCM we find by the relation. Okay, so the next question is question number 5th. Very interesting, very important question. We have to check whether the 6 power n can be end with the digit 0 for any natural number n. So we have to check, is there is exist any natural number small n by which the 6 power n end with the digit 0. So which number end with digit 0? So firstly we should know that the number end with digit 0, example that 10, 20, 30, these all the numbers are end with digit 0. So what about these numbers are divisible by 5? So the first clue, we find out that the numbers end with digit 0 divisible by 5. Okay, so now the next one. If the number 6 power n for n small n belongs to n. What is the small n belongs to n? The meaning is that small n is from natural numbers. Small n is from natural numbers. Okay, so that's why then if the number 6 power n end with digit 0, then it should be divisible by 5. Okay, the meaning is that when 6 power n divisible by 5, so there should be any prime factor 5 exist in the prime factorization of 6 power n. Okay, that is in the 6 power n prime factorization there should be one of the prime factor 5, but we know that 6 power n can be written in the form of 6 into 6 into 6 also. When we just factorize 6, then it can be written as 2 into 3, 2 into 3, 2 into 3. So we've noticed that in the 6 power n prime factorization only 2 prime factors are repeating, 2 and 3, but not 5. Okay, and what here we have write, if any prime number 5 contain in the prime factorization of 6 power n, then it will end with digit 0, otherwise not. Okay, so here a contradiction is going to create. Okay, which contradiction? That is, it is not possible to get the prime number 5 because there are only two prime numbers. The number 1 is 2 and the number second is 3. They both are repeating. Okay, so now this is not possible because the prime factorization of 6 power n contain only the prime factors 2 and 3, not 5. So by the fundamental theorem of arithmetic, because the fundamental theorem of arithmetic is saying that prime factorization of any composite number is unique. Okay, it will not the change, it will be unique. So by the fundamental theorem of arithmetic, we conclude that there is no other prime numbers except 2 and 3 in the prime factorization of 6 power n. So there is no natural number, small n, there is no natural number small n for which 6 power n end with the digit 0. Okay, so this type of question we prove by the help of some of the contradiction, right? So next, so the next in exercise 1.2, okay, the next question is question number 6. So in question number 6 we have to explain why the numbers 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite number. So why we just counting these number as a composite number, we have to check or we have to explain. So the first 7 into what is the composite number? Firstly you should know. Okay, composite number are those number which can be expressed as the product of prime, which we learned in the starting of today's lecture, right? What is composite number? Which can be expressed in the product of prime. So now we are taking the numbers 7 into 11 into 13 plus 13. So in this number we can see that 13 is common. So we will take the common 13 and in the bracket we will found it will be 7 into 11 plus 1. Okay, yeah, correct. So 13 into 77 plus 1, then it will be 78. So 13 into 78, but 13 into 78. So 78 prime factorization if we will do, then it will be 13 into 2. So 13 into 2 into 3, right? So product of primes. So 78 can be written as 13 into 2 into 3. So here we found that 7 into 11 into 13 plus 13 can be written as the product of primes. Okay, so this is a composite number. Firstly we prove that. Okay, so how we prove that? We just solve the calculation taking some of the common terms and we change the numbers into the product of primes. If the number change into the product of primes, then it is a composite number. If not change in the product of primes, then it is not a composite number. Okay, this concept you should keep in your mind, right? The next one is 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. In both we can take 5 as a common, right? And in the bracket we will see that it is 7 into 6 into 4 into 3 into 2 into 1 and plus 1, right? So it will be 5 into, we will multiply all of them, that is 7 into 6 42, then this is 24, 42 into 24, then it will be 1008 and 1008 plus 1, that is 1009. So it is 5 into 1009. So this is also product of prime. So we also see that this number is also product of prime. So finally we can say that this is also a composite number. So here we explain in this question, that is, they both number are composite number. But before explaining composite number, you should know what is the meaning of composite number, right? So this question also we have done. The next one, question number 7. There is a circular path around a sport field. Sonia take 18 minutes. There is a circular ground, okay, and in this circular ground, Sonia take 18 minutes to drive one round. Sonia take 18 minutes to complete one round, and while Ravi takes 12 minutes for the same, that is Ravi complete one round in the 12 minutes. Whatever the informations we have to given, save all the informations in the small part in your mind one by one, okay, then it will be very easy to solve the question. Okay, so two character we find out in this question, one is Sonia, the second one is Ravi. Okay, they both complete one round in 18 minute and 12 minute. Now what is the question? Suppose they both start at the same point at the same time and go in the same direction. The meaning is that if they both are going to start from that point and going in the same direction, that is, if we are taking that is they both are going in clockwise direction, okay, from the same point, then we have to find that is how many minutes they will again meet at the starting point. Sonia and Ravi, they both are just start their journey from the same point. They both are start their journey from the same point. They are just moving in the same direction in the circular path. They are moving in the same direction. One is Sonia, the second one is Ravi. Okay, Sonia take 18 minutes to complete one round and Ravi takes 12 minutes to complete one round. Now we have to find out after how many minutes they will meet. Okay, this is the main question which we have to given. So now we check, that is how we will find out them. Okay, so here a sport field we draw, okay, and circular path, so this is a circular path, right. Now Sonia take 18 minutes. Here this is the starting point we have fixed. Okay, now from this starting point, Sonia take 18 minutes to drive one round. Sonia take 18 minutes to drive one round. Okay, in the similar way, in one round 18 minutes, in two round 36 minutes, in three round when taking three round then 54 minutes. So this means that she will come to starting point after 18 minutes. Right. In the same way, Ravi also take 12 minutes to drive one round. The meaning is that 12 minutes, one round, two round, 24, three round, 36 minutes. So when Sonia drive two rounds, then it complete two round in 36 minutes and Ravi complete three round in 36 minutes. That is, after 36 minutes they both are meet again. Okay, but which concept we will apply here? So you can see that that is he will come to starting point after 12 minutes. This is for the Ravi. But here which concept we will apply? So we found that it takes two rounds, it takes three rounds, she takes two rounds and he takes three rounds to complete to again meet the same point, okay, after 36 minutes. So here we are taking the LCM. So the concept is going to use LCM of 18 and 12. If we will find the LCM of 18 and 12, then we will find that they will meet again the same starting point. Okay, so here we will find LCM of 18 and 12. So firstly we just find the concept, that is which concept we have to apply. Okay, so the 18 prime factorization we will do, then it will be 2 into 3 square, and 12 prime factorization we will do, that is 2 square into 3. Then we can easily find the LCM of both of them, and we just find out that it is 36. So in 36 minutes Sonia arrived at starting point after making two rounds. we already see by the table, and also Ravi take 36 minutes just from the to come the same starting point, making 3 rounds. After 3 rounds, Ravi just coming on the same starting point, and after 2 rounds, Sonia just coming on the same starting point. Okay, so now they meet each other at the starting point after 36 minutes, right? So this is the one of the application part also, that is how we apply the HCF and LCM in the application part. So we move to the next question and also see the concept how we will apply. Now there are 156, 208 and 260 students in a group A, B, C respectively. Okay, there are 3 groups. In 3 groups we have to given the number of students, and buses are to be hired to take them from a field trip. Okay, so there is a trip, that is they have to journey, they all have to journey, okay, for that trip, and we have to find the minimum number of buses to be hired if the same number of students to be accommodated in each buses. Okay, in each buses, if same number of students to be accommodated, then we have to find how many buses are required. That is example that in a bus we have 42 seats. Okay, so now we have to calculate how many buses required, because in the multiple of 42, okay, we have to just check the number of buses. So it's the same concept we have to find out here. The number 1, minimum number of buses to be hired if the same number of students to be accommodated in each bus. So for that, the number of buses will be minimum if each accommodate the maximum number of students. Okay, if you have to find the number of buses, the number of buses will be minimum when each bus has the maximum number of students. Okay, so now we also want to minimize the transportation cost. Okay, so that's why we are doing this concept. The number of students in each bus must be, so how we will find the number of students in each bus? So it will be the highest common factor of 156, 208 and 260. So here the concept of highest common factor we will use. Okay, so here the prime factorization firstly we will do of the 3 numbers. So firstly 156 prime factorization. So we can see that 156 prime factorization is divided by 2, then divided by 2, then divided by 3, then 13. So the prime factorization of 156, 2 square into 3 into 13. In the similar way, prime factorization of 208, it will be, you can also check in the rough prime factorization of 208, then it will be 2 4 times and 13 1 time, right? So 2 raised to the power 4 into 13, and also 260 prime factorization you can also do in the rough, and you can see that it will be 2 raised to the power 2 into 5 into 13. Okay, so we will write down 2 raised to the power 2 into 5 into 13. So now the HCF of all of them, the common prime factor we will find out, and you can see that the common prime factor all of them is 2 and 13. Okay, so 2 with the least power and 13 with the least power, so it will be 52. So I think the 52 students should be in one bus. Okay, so we found that in each bus 52 students can be accommodated. That is, we can arrange, okay, 52 students in a single bus. So now we can easily find how many buses required, because total number of students we know, and in each bus how many students we can accommodate, we also find this one, right? So now the minimum number of bus required, total number of student upon 52. So the minimum number of buses are required, total number of student into over 52. So total number of students are 156 plus 208 plus 260 over 52, and this will be equal to 624 over 52, and 624 over 52, then it will be 18 buses are required. So here 18 buses are required to make the journey of a trip. Okay, right. So this is we have done. The next question, or the extra question, we have to given the base based as an application of fundamental theorem of arithmetic. A monsoon has to fit Amazon has to fit a bathroom with a square marble tiles of largest possible size. The size of the bathroom is 10 feet by 8 feet. What would be the size in the inch of the tile required that has to be cut, and how many such tiles are required? Okay, so here Amazon has to be fit in the bathroom with the square marble. Okay, so we have to just fit a square marble tiles of largest possible size, and bathroom size we have to given here 10 feet by 8 feet. Okay, so then let's see how we will find. Firstly, the length of the bathroom is 10 feet by 8 feet. So the length of the bathroom 10 feet, then it will be 10 into feet we have to change in the inches, so we will multiply it by 12 because we know that 1 feet is equal to 12 inch, so it will be 120 inch. In the similar way, breadth of the bathroom we will also found, then it will be 8 feet, so multiply 8 to 12, then it will be 96 inch. So firstly we find the length and the breadth of the bathroom in the inches. Now area of the bathroom is area of the bathroom, that is length into breadth, and it will be 120 into 96. Okay, now what would be the size in the inches of the tile required that has to be cut? So now when we have to find the tiles, which size of tiles required, so what we will do, we will find the HCF of 120 and 96. So now you can find the HCF by the prime factorization or by the Euclid division lemma. According to the Euclid division lemma, you know that we will divide the greater number, that is 120, by the 96, and it will be divided by 1. So we found that is the remainder is 24. Okay, so the 96 divided by 24, and we'll found that it will be 0. So because we know that the dividend is equal to the divisor into quotient and plus remainder. Okay, so now we will write down here 120 is equal to 96, that is the divisor, into quotient is 1 and plus the remainder term is 24. Again we will apply the Euclid division lemma between 96 and 24. So we can check that 96 can be written in the form of 24 into 4 plus 0. Okay, so now the last, so the HCF of 120 and 96 is the last divisor 24. Okay, so this will be equal to 24. So here first we find the highest common factor of 120 and 96, that is we have find the highest common factor of length and breadth of the bathroom. Okay, so as we find, we know that area of the bathroom is this one, HCF is 24. So now what would be the size in the inches? So the side of the tile will be equal to 24. Okay, so the tile size we find out 24. Now area of a tile, because we want square marble tiles, so the area of the tile is side square. So the side square, that is 24 square. So area of a tile is 24 into 24, that is number of tiles. Now what we will do, we just divide the area of the bathroom by the area of the tiles. Okay, so area of the bathroom, total area of the bathroom divided by area of each tile, then it will be 120 into 96 divided by the 24 into 24. So they will be cancelled out by 5 and 4 and it will be equal to 20. So the number of tiles required is 20. Okay, so here we find the number of tiles in the bathroom. Okay, and the next question, we have to find the largest number that will be divided by 445, 572 and 699, leaving remainder 456 respectively. This is very important question for the sake of mathematics standard student. Okay, so whenever we have to given the leaving the remainder 456, so firstly in the solution what we will do, we subtract the remainder from 445, 572 and 699. Okay, then the numbers will be 441, 561 and 693. Now we have to find the HCF of 441, 567 and 693. So now we can find the prime factorization of 441. So we can check the prime factorization of 441 are 3377. Okay, so 3 square into 7 square it can be written, and 567. So for the sake of 567 we will see that 3, 3, 3 and 3 and 7. So 3 raised to the power 4 into 7 we will write down, and the next one is 693. So we will do the prime factorization of 693, then it will be 3, 3, 7, 11. Okay, so 3 is square into 7 into 11. So it will be 3 square into 7 into 11. Okay, so now we can find the HCF of all of them, and we just see that the common prime factors are 3 and 7 with their least exponent, that is 2 and 1. So we will find that HCF of all of them is 63. So the largest number that divide all the three numbers leaving remainder 4, 5, 6 is 63. So the largest number is 63. So by 63, when we will divide 445, by 63 when we will divide 572, and by 63 when we will divide 699. So the remainder will be 4, 5 and 6. Okay, this is we find out in this question. Next question. Find the smallest number which when increased by 17 divisible by both 520 and 468. So here we have to given the two numbers 520 and 468. The least number of 520 and 468, when there is a least number, that is we have to find the LCM. Okay, so to find the LCM of 520, we should know that the prime factorization of the 520 are 2, then 2, then 2, then 5, then 13. That is 2 raised to the power 3, 5 into 13. Okay, so we will write down 2 raised to the power 3 into 5 into 13, right? In the similar way, we have to find the prime factorization of 468. So we can see that the prime factorization of 468 will be equal to 2, 2, 3, 3 and 13. Okay, so this is 2 square, 3 square and 13. So this is 2 square, 3 square and 13. Okay, so here we find the prime factorization. Now we can easily find the LCM. So LCM is we have to take all the prime factors 2, 3, 5 and 13 with their highest exponent, and we will multiply all of them. Then this will be 4680. This is the LCM we find out. But now find the smallest number. So the least number divisible by both of them is 4680. This is firstly we will find out. Now we have to find the smallest number which when increased by 17. So we assume that this smallest number is small x, which when increased by 17, that is x plus 17, is exactly divisible by both of them. Okay, so here x plus 17 will be equal to 4680. So we can find out the value of x is 4680 minus 17. So the value of x will be equal to 4663. Okay. So here we find that 4663 is the required answer, or is the required smallest number, which when increased by 17 then exactly divisible by both 520 and 468. Okay, so here in this lecture you understand about the fundamental theorem of arithmetic, and also you understand that is how we are going to taking the help of fundamental theorem of arithmetic to find or to evaluate the highest common factor and lowest common factor, and just we also find an interesting result, a relation between the product of two numbers and their HCF and LCM, and we solve many of the applications based on fundamental theorem of arithmetic. Thanks to all of you, my dear students.